7.2 Electrostatic Notes: the atom, conductors, and insulators, as well as polarization. Whether you have realized it or not, you have always experienced static electricity. Whether it is a shock you receive when you touch a doorknob, bzz, or the sparks of electricity you see when you pull a wool blanket off the sheets of your bed, you are always experiencing static electricity. From the electrostatic simulation that we haven't done yet, we discovered, or did we, that objects can be positively charged, negatively charged, or uncharged, which we call neutral. So there are three things that an object can be. It can be positive, negative, or neutral. We also learned, or will learn, that like charges repel each other, meaning two positives will repel each other, or two negatives will repel each other, but unlike charges attract each other, unlike being a positive and a negative. So like charges, positive and positive, repel, or negative and negative repel. That's a symbol for positive, a symbol for negative. But unlike charges, like positive and negative, will attract each other. They'll pull each other toward each other. Like charges push each other away. Unlike charges attract each other. Like charges push each other away. Unlike pull each other closer. What causes an object to gain or lose charge? In order to understand this, we must remember the structure of the atom. An atom is the smallest amount of an element that keeps its chemical properties. Atoms are made up of protons, electrons, and neutrons. Protons, electrons, and neutrons. Those are the three building blocks of atoms. And we have them in this picture below. So here, this gray thing is supposed to be the atom. In the middle is the nucleus. And the nucleus, as you can see in this second picture, is made up of protons and neutrons. Those are both in the nucleus. The electrons are outside of the nucleus. They're actually in all this gray area here. They're kind of floating around. Kind of like we have the sun in the middle of the solar system and the planets revolving around it. Same thing with atoms. We've got the nucleus made of protons and neutrons in the middle, and then the electrons are roaming around it. What is the charge of the electron? Electrons are negative. That's why in this diagram here, they've got little negative signs, the electrons. What's the charge of the protons? Well, if you've looked at that picture, you can see that protons are positive. P for proton, P for positive. And what about the charge of the neutron? There's nothing drawn in there because neutrons are neutral, just like the name suggests. Neutron, neutral. Which part of the atom seems easiest to remove? Well, if you look at this picture again, you've got the protons and neutrons in the middle. They're all clumped together in the middle. But you've got these electrons that are spread out and roaming around the outside. So the easiest one to remove, the easiest one to grab, would be these guys on the outside, the electrons. The electrons. Because they are farther out. What needs to happen to have a positively, negatively, or uncharged object? Hint, only electrons can be gained or lost. So for this, I'm assuming that we start off with a neutral object. Most objects that we can see in the room are neutral. They don't have charge. So if we want it to become positively charged, actually let's start with negative. If we want it to become negatively charged, we need to add electrons to the object. So electrons, since they're the easiest to move around, to take away or add, Electrons can be gained or lost, added or subtracted. So if we want something to be negative, we're going to add electrons to the object. To make something positive, we cannot add protons because those are hard to get to. They're in the middle of the atom. So instead, we need to do something with the electrons. We can't add more electrons because that would make it negative. So instead, we'll take away electrons. Taking away negative electrons leaves you with more positives, because in the beginning, the number of, or rather for neutral atoms, the number of protons and the number of electrons are equal. So you have to add electrons to make it more negative, or take electrons away to make it more positive. So if you want it to be uncharged, you leave it alone, since the number of protons equals the number of electrons. So they kind of cancel out. They're neutral. Remember, it's only the electrons that you can take away or add. The protons are stuck in the atoms, so we can't do anything to them. Let's flip to the next page. Here's an example of charging something. When you rub a styrofoam cup on your head, which of the following statements are true? Please explain. When I rub a styrofoam cup on my head, it gives me attractive energy. That's not true. The styrofoam cup becomes negatively charged by transferring protons. Well, we can't transfer protons. We can't change how many protons there are. So that's not true. The styrofoam cup becomes negatively charged when electrons are transferred from your hair to the cup. Exactly. We can only move or transfer negative electrons. So, some of the electrons move from your hair to the cup, making the cup negative. When the cup has more electrons, it becomes negative. So then we have something called conservation of charge. Oh, that word, conservation, we love it. We've talked about conservation of momentum, conservation of mechanical energy. To conserve something means to keep the number the same. So, the principle that electric charge is neither created nor destroyed, but can be transferred from one object to another, that's what conservation of charge means. In other words, the total amount of charge doesn't change. All that changes is where the charges are located. Are they transferred from one thing, or are they in the other thing? Just like when we had mechanical energy, and we had potential energy and kinetic energy, and when the total amount had to always be the same. So if potential energy got lost, the kinetic energy was gained. So same thing here, the amount of charge never changes. So if you have 5 electrons on one atom and 3 on the other atom, then if those 3 electrons go from one atom to the other, we still have a total of 8 electrons, just like we did in the beginning. All that's changed is where the electrons are. Are they in one atom or are they in the other atom? In order to charge a material, electrons must be moved from one object to another. So that's what we're saying here with conservation of charge. To charge something really means you're just moving charge from one thing to another. And there are 2 types of materials as far as electric charge goes: conductors and insulators. Just like we had conductors and insulators in heat. In heat, a good conductor is something that allows heat or thermal energy to flow through it. So, for electricity, Conductors are materials that allow electric charge to flow through it. So they let charges move more easily. It turns out that good conductors of heat are also usually good conductors of charge and electricity. That's because they have a lot of electrons that can move around. That helps transfer the heat, also obviously transfers the charge. What are some examples of electric conductors? I'm going to let you find that out on the internet. Use the internet to find some examples of electrical conductors. Now, a material that is a poor conductor of electricity is going to be called an insulator. Just like a material that doesn't conduct heat very well, doesn't allow heat to flow very well, that's called an insulator. Something that doesn't allow electricity or charge to flow very well is called an insulator. And again, I'm going to allow you to use the internet to find some examples of electrical insulators. I hope you've enjoyed the video.